Welcome to Cornerstone Home Inspector Education Center. Tonight we have electrical panels. This presentation is going to cover common defects, what we find in panels during an inspection. We're going to explore safety issues, inspection requirements, proper identification techniques, reporting. We'll go through some narratives. Stan and I are going to do this webinar together. Just a couple of notes. You'll get your certificates most likely either today or tomorrow morning by noon. And December 2nd, we have radon and air and water going to be presented. And January 5th, we will also have a 2-day event for anybody who's a licensed Connecticut inspector will be able to satisfy their law seminar requirement, which is a 3-hour requirement in Connecticut. And we will have two 90-minute webinars, January 5th and 6th. And you can find all that information on our website under calendar of events. So why don't we get started today? So what we've been putting in the webinars are Connecticut state standards, but these standards also apply to other states. And in Connecticut, on an electrical system, the inspector shall inspect the service drop, the service entrance conductors, cables, raceways, the service equipment, main disconnects, the service grounding. You're going to inspect the interior components of service panels and sub panels. That's for Connecticut inspectors. In Rhode Island, you are not allowed to do that. We want to inspect over current production devices. You're going to do a representative number of lighting fixtures, switches, receptacles, and ground fault circuit interrupters. In your reports, you're going to describe the amperage, voltage rating of the service. You need to put in the location of the main disconnect, location of subpanels, and the wiring methods, if it's Romex, BX. The inspector shall report on the presence of solid branch aluminum wiring. The inspector is not required to inspect remote control devices unless the device is the only control device. I had one of those today, which was a fan that only worked by remote. Alarm systems, I highly suggest that you do not test those and their components. Low voltage wiring systems, I've only seen one or two of those and their components. Solar systems, any on-site generators, ancillary wiring systems, components not part of the primary electrical power distribution system. And we are not required to measure amperage, voltage, or impedance. Stan?
Yes, so what is an electrical panel? The electrical service panel, also called the breaker box distribution panel, serves as the central hub for distributing electricity throughout a home. It receives power from the utility company through the service entrance conductors, dividing it into separate circuits, and provides overcurrent protection for each circuit through circuit breakers or fuses. We will touch base today a little bit about the service drop as well. It's not just the panel here. We're going to get into that a little bit. When functioning properly, the panel protects the home's wiring from overheating and potential fire and automatically disconnecting power when circuits become overloaded or short circuits occur. The panel also provides a convenient location for manually disconnecting power to specific circuits during maintenance or emergency. So it's a critical role in home safety. And we really have to look at that or remember that when we're doing the home inspection. Every amp of electricity flowing through the house passes through this panel, making it one of the most important safety devices in the residence. Understanding how it works, what can go wrong, and how to inspect it properly is fundamental to competent home inspection practice.
Components of an electrical panel. So we have a diagram here, and we'll go through these. We're not going to go into depth on anything tonight, but we will go through these. In a panel, we have our two insulated hot wires from the meter that come in. We have our main disconnect breaker. We have our neutral and grounding bus bars. Double pole breaker control in the sub panel for higher voltage equipment. Your hot buses or legs, which the circuit breakers click into. We have knockouts on the side and bottom of the panel, our grounding wire, removable bar joints, neutral and ground buses. Right here, our bus bar connector. We have our bonding connector on either side of the neutral and ground buses. We have our neutral grounding bus bar, our branch circuits, and then our bare neutral ground wire from the meter coming in. So these are components. We're going to talk about some of these components as we go through, but this is a general outlay of what you're going to be looking for. When I come into the panel, you know, not to summarize the whole webinar, but when you come into a panel, I usually start from top to bottom. I'm looking at my feeders. I'm checking the size of them. I'm checking the main disconnect, making sure our bus bars are connected. We've got our bonding connector. Any knockouts, is the panel properly labeled? Double tapping, rust and corrosion. We're going to go through all this, but I usually try to start and work from the top down.
So preparing for the inspection, there's essential tools and equipment that you need. Proper equipment ensures thorough inspection while maintaining safety. Your basic toolkit should include a flashlight for dark places, dark panels, a non-contact voltage tester to verify power presence, a receptacle tester for checking downstream circuits, and appropriate personal protective equipment. I don't really have that. Many inspectors also carry a digital camera for documentation, a screwdriver for removing covers where safe and appropriate, and a thermal imaging camera for identifying hotspots. I want to mention something about removing covers. I did a house that was 1 year old. I was the first person to take that cover off after the electrician buttoned it up. I took a quarter turn on one of the screws, and that screw must have been embedded in one of the wires because it almost blew the panel cover off. It was all scorched. Now, luckily, and this was a house raised off the ground on the beach. So if I was startled because it was right in the hallway and there was a stairway coming up from downstairs, I could have went right down those stairs. But the homeowner and the realtor and the buyer were right there, and they saw that it was not my fault. So when you least expect it, these kinds of things can creep up. Now, at least they were there. I did document in my report what had happened, but nobody had ever taken that cover off before me. So it was a setup. But be careful. You have to be careful. Before approaching any electrical panel, adopt a safety first mindset. Electrical inspection carries inherent risks, like I was talking about, including potential for shock, arc flash, and exposure to live conductors. Never rush panel inspection and never proceed if you feel uncomfortable with conditions you observe. Your safety is more important than, excuse me, any inspection finding. So just to reiterate, flashlight, non-contact voltage tester, receptacle tester, camera for documentation, safety glasses, I wear them all the time. Insulated gloves, non-conductive footwear, flame-resistant clothing are recommended. So, okay, Jim.
Yeah, I agree. Pay attention where you're at when you're taking off that panel. Okay, so looks like I get all the fun slides today. More information about the panel. This is a little bit of recourse of what we're doing. I'm not going to go over this side because we've already done it. But in the main panel, the bonded neutrals and grounds. Neutral and grounds are bonded together within the main service panel. That's done right down here. In a sub panel, they would be separated. A bonding jumper connects the neutral bar to the panel case, ensuring continuity. And I believe that's right here. Okay. Grounding electrode connection. The grounding electrode connector connects the external grounding points, such as grounding rods, metal pipe, and other electrodes. Again, shared bars for neutral grounds. Branch circuit neutral and equipment grounds typically share the same bus bar in some panels.
Jim, can you go back to that slide for a minute?
Yeah, absolutely.
Do you guys know what a UFR or UFR bond is, or ground? It's usually embedded in the foundation, in the concrete. The other 2 weeks ago, it was going in the stone foundation, two of them, and they have to be in contact with the concrete for a certain amount of time or feet. I'm sorry, and then that is the bonding of the electrical panel. You don't see them much around here, but in other parts of the country, they're kind of common. Okay, Jim.
So,
Go ahead.
oh, no, it's your turn. Sorry. You're good.
In subpanels, the neutral in a subpanel neutrals are isolated and not bonded to the panel case. The ground bar is bonded to the subpanel case to provide a path for fault currents. Subpanels require a 4-wire feed for proper separation, 2 hot conductors, a neutral, and equipment ground conductor, and no bonding screw or strap. There should be no bonding screw or strap connecting the neutral bar to the subpanel case. So among all the other things that you would look at in any panel, this is something you add. You need to look at and identify if the bonding screw is still in there or the strap. And I refer them to a licensed electrician. And then separate ground rod is required for subpanel only if it is installed in a detached structure. I think we're going to get into other things as we go. There's a couple of things in that picture that you may want to call out, but I think we're going to address that again.
And just to jump in just a little bit, because for some newer inspectors, I know that when I first started, electrical seemed a little bit overwhelming, especially if you don't have a background in it. The neutral is carrying the return current. So you could think of the neutral as just a path for the electricity to run in, and the ground carries any fault current. If there's a short or a problem, that's where that's carried. So the two different key rules. Number 1, individual neutral connections. Each neutral must be on its own screw. Double lug neutrals are not permitted. Multiple ground connections are allowed under a single terminal if the terminal is explicitly listed for it. Continuous grounding electroconductor. The GEC must be continuous, unspliced, unless an irreversible connector is used. So I see this a lot, Stan. I don't know what your comment is on it, but I'll go into an older panel and I'll see a lot of double tapping on neutral and grounds. On the older panels, I don't call them out as much. On the newer panels, I will if I feel it's, not wired correctly.
I have I apply this a lot to decks and to electrical. If it's an older house, I tell them that their electrical system, or even their deck for that matter, may not meet current or does not meet current building department requirements, and they should have a contractor come in for the deck or an electrician come in for the electrical panel and bring it up as close as they can to current requirements. And they'll go, well, why is it not safe? It's been in this house and we never had a problem, or they never had a problem. I said, no, it's functional, but it could be safer. Just so they know that it's not going to be the way it would be today. And I'm not pointing out everything that's not either. My turn. So panel components, what do? Bus bars distribute electricity throughout the panel to various circuit breakers. Circuit breakers, essential devices that protect circuits from dangerous overloads and short circuits. The neutral bar serves as the central collection point for all neutral wires within the electrical system. And the ground bar provides a critical connection point for all equipment grounding conductors.
Branch wiring conductors. We want to check for proper sizing, ensure wires are correctly sized to match the capacity for safe operation. Insulation integrity. We want to look for maintaining wire insulation without damage, discoloration, is crucial for preventing electrical hazards. We're going to look for melting and scorching. Secure connections, achieving a tight, reliable termination at breakers prevents loose connections and potential arcing. And proper routing, organizing wire neatly within a panel, avoiding overcrowding for better airflow and easier maintenance. I've opened up, well, Stan's opened up a lot more panels than I have. But when I open up a panel now, I immediately know, if I see something like the two pictures on the right, that just sort of gives me a good feeling that someone cared when they wired this panel. And not that it makes my job easier or I slack off, but when you open up a panel and you're seeing wires over circuit breakers or, a lot of splices, you need to start calling that stuff out if you haven't. And proper sizing. Yesterday I did a house for the second time in a year. And I look at the panel and the client goes to me, it's 200 amp service. And I had done the house last year and I said, no, it's not 200 amp service, it's 100 amp service. And she pointed to the main disconnect. And I knew because I had done the house before and I popped open the panel and I see that main disconnect has no feeders. The feeders are on the left side of the panel to a 100 amp breaker. So you have 100 amp service and the size of the wire was appropriate for a 100 amp service. So the homeowner thought that they had 200. The buyer thought that they had 200, but they didn't. And the homeowner didn't know that, excuse me, because I did that inspection. They never got it changed. She didn't upgrade. So you got to be careful. Just don't look at you got to look at the wire size too.
So mismatch breakers versus wire size. So AWG stands for American Wire Gauge. It's a standardized system used in North America to denote the diameter of electrical conductors. The smaller number equals thicker wire. Example 10 AWG is thicker than 14 AWG. Larger number, thinner wire. Examples 20 WAG is thinner than 14 AWG. The gauge affects current carrying capacity and amperage, resistance, the allowed distance or voltage drop. So a 14 gauge wire typically uses a 15 amp circuit. We all should know this. And a 12 gauge wire typically uses 20 amp circuits. Sometimes the insulation part, you're looking at two wires that look very similar. When you're looking at the insulation, you have to look at the wire coming out if you can't. Sometimes there's stuffed in the breaker so far that you can't see the copper, but sometimes it's misleading just looking at the insulation. That they could be very close right. In that way. So if you have any questions, write it up and tell them to have an electrician look at it. That's your out if you're unclear, and you really need to be very careful with the electrical system. Not that you don't need to be careful with anything else, but you're not, if you're not an electrician, you're not unless you're an electrician, you're not an electrician. So be very careful on how you call things out.
Okay, overloaded circuits. A 15 amp standard circuit, typical rating for lighting and general purpose outlets. A 20 amp is for kitchens and bathrooms, required for kitchens and bathrooms receptacles. A 30 amp would be for larger appliances like dryers and some air conditionings. And a 50 amp heavy, that's a heavy duty required for ranges and some HVAC systems. So again, this is something that you need to look at when you have the panel open. And when I'm outside doing a condenser, I look at the max fuse breaker and I really try to check to see if everything is sized properly, because a lot of times it's not. A lot of times you'll see a homeowner run a sub panel out to a shed or a detached garage. I can tell you, if it was a homeowner special, I'll see a lot of times, I saw one in Bristol I did a couple of months ago. It was 15 amp at best, and it was tied into a 100 amp breaker. It's like, what's going on there? The electrician no way did that.
So defective breakers. probably not going to really be able to tell during a home inspection, but a defective breaker um, will not disconnect power during an overload, creating a fire hazard. And you know what I think we touched base a little bit on some of the panels that have had these problems in the past that are problem panels now. There, when I was starting off in this profession, they were telling people to exercise their breakers every 6 months to make sure that they actually function, because they could get stuck in the on position. I don't think many people do that. Then I read again that you shouldn't be doing that. That the only time it should trip is during an overload. So here again, you get two opinions against each other. But nuisance tripping, breakers that trip without actual overload, disrupting power unnecessarily. Physical damage, cracked housing, burn marks, melting, indicating serious problems. Some of those are hard to miss, but you still got to look in there to find them. And testing limitations. So standard inspection cannot fully verify breaker functionality. So you don't want to mention that at all.
Double tap breakers. What is a double tap breaker? A double tap breaker occurs when two conductors are terminated under a single breaker terminal not designed for multiple conductors. Most standard breakers are designed and listed for only one conductor per terminal. Why is it hazardous? I explained to my customers that double tapping creates several problems. A terminal may not properly secure both conductors, leading to loose connections that can generate heat and can result in arcing or fire. Additionally, if one conductor is smaller gauge than the other, the terminal may grip the larger wire while the smaller one remains loose. Even if the connections appear secure during installation, thermal cycling, the heating and cooling, and vibration can cause them to loosen over time. So this picture is a little hard to see, but we've got that's a triple tap, which I see a lot. There's some double taps here, and you got to take good pictures and point them out. There are some panels, like a square D panel, that are rated to take double taps. When that happens, if it's a newer panel, I will note the double tap. I will turn to the client and say, it's my understanding that some of these breakers in the square D can take a double tap, but that's up to an electrician to decide, not me. So I'll take a picture of the double tap, put it in the report, and that's up to them what they do. A lot of times when you're inspecting, you're going to have an agent there. And I've run into this numerous times, and the doorbell is 95% an American Home Pro double tap, the little transformer for the doorbell. And you'll call it out, and the agent will look to your client and go, that's not a big deal. There are always double taps for the doorbell. And I just, at this point, I've been doing it a while, and the client will look at me for reassurance, and I'll say, well, we're going to put it in the report, and you're going to have it looked by an electrician because your agent's not an electrician.
So damaged, melted insulation, kind of important because there's more going on, obviously, than that's creating that damage there. So the wires could be loose connection, could be undersized for the or the wire undersized for the breaker.
Right.
So you got to call that out. You got to find it and call it out. And I would put a rush on that in my report because we don't know if that was corrected or not. And they never, a lot of times the wires barely get to where they want to go. And somebody might have tightened that lug up or corrected whatever the problem was and couldn't cut that wire back. And I mean, I don't know about that one, but cut the wire back and get it back to the breaker so they leave it the way it was. Just call it out and say that it needs immediate attention. Well, that's what I would do. So you want me to continue, Jim, on these?
Yeah, why don't you go through some of these pictures?
So loose connections. That's probably one of the single most important. If you really want to be crazy, you can yank on all these wires and see if you can pull them out. But loose connections cause a lot of problems in houses, a lot of damage. So there you see something that you would not miss if you took the cover off. But how about these panels that are painted to the wall and you're not going to take them off? You're never going to find stuff like this. So that's why you got to cover yourself. I don't think we have a slide here, but you got to cover yourself when you can't take that panel cover off. I make a statement saying that the cover should be taken off and the inside of the panel look for defects.
Yep.
So on the right, that picture there is, again, loose connections, probably that are creating problems there. Is there 2 wires on that big fat nut in the middle there? So
I don't
these
think
are,
so. I think the screw's not in. That's what they're showing there. That's why it's loose.
yeah, it looks like it's kind of backed out there. So these are why we constantly hammer on these types of things, because they're small, they seem insignificant, but they do, the electrical system, even a loose lug is a big issue.
Right.
Wire routing. I see this quite often. This looks familiar. Is this one of my pictures, Jim?
Yes.
I don't know how I remember that, but the whole house was like this. Somebody just ran that stuff, and it's old stuff too. It's been like that for a long time. It's old BX.
Yeah.
So that's just nutty. You got to have all that secured. Corroded components. That's probably pretty bad right there. There's a lot of problems there, but you see corrosion in different levels. Lightly corroded bottom of the panel, but that could get worse. To me, when the breakers are the lugs are corroded, that's a big problem because the wires are going to loosen, and for me, if there's rust on a breaker, the breaker should be replaced, in my opinion.
Here's an example of where you've got double tapping of the ground wire on your bus bar, and this panel's so old that was probably okay back then, and that's what they did.
And I always recommend, when I see rust in the panel, that they need to dehumidify the basement.
Yeah.
Even though I put that in as part of keeping your basement humidity down anyways, but that's 2 now reasons to do it. So go ahead, Jim.
I'll go. Incorrect breakers. Manufacturer warning. Breakers labeled only for rated enclosure must be used in specific panels. I've seen a lot of times. I did a house one time where I take the panel off and the breaker popped right off the bar. The power went out in the basement, and everybody just looked at me. I'm like, well, that's an incorrect breaker for that panel, and they were using the pressure of the dead front or the cover panel to hold that in. Panel compatibility. Panel covers list compatible breakers to ensure system integrity. Safety risk. Mismatched breakers may fail to trip, fit improperly, or violate electrical codes. So if you're in a square D panel and you're seeing, weird breakers in there, you got to call that out. I'll take this next one. Improper labeling, clear identification. I can tell you that's one of the biggest questions I get. I'll go through a whole panel and I'll say, the panel's buzzing and there's a slight fire happening, and the client will look at me and go, is it labeled? Like that, we have other issues other than labeling, but we want proper labeling, clear identification, so that if something happens and you need to shut something off, you know exactly where to go. And there should be a complete circuit directory inside the door panel. You're up.
Okay, outdated panels. I think there's a difference between outdated panels and unsafe panels, but we'll call it for what it is. So fuse boxes, obviously, I think there's still some out there. Fuses, the old timers thought the fuses were the best way to go, right? Because if there was an overload, they were going to blow. Whereas a circuit breaker, like we discussed before, may not trip. So they loved them. But especially now with insurance companies not wanting to insure houses with breakers, fuses, if you see fuses, I think it's best to recommend upgrading to a circuit breaker distribution panel. Split bus panels. I personally don't see a lot of them, but they were pretty popular from the 50s to the 80s. So there's no main breaker. You're using 6 breakers to shut the entire panel down if you needed to shut all the power off. So if I see them, I also make the recommendation to upgrade to a modern panel. So we all know about Federal, Pacific, and Zinsco. Uh, I don't. Once I see them, I'm telling them. And here's the problem. I know a local electrician who um, goes to somebody's house to work on. He's got a Federal, Pacific, or a Zinsco. Um, he tells them that they're unsafe panels and should be well, if he sees indications of a past problem, he's going to beat that uh, to death a little bit. But um, he I don't even think electricians can get somebody to change the panel. They're going to have to, heed the warning and do it on their own. But he still works on it and tries to fix the problem and tells them they have a hazardous panel and it should be replaced.
Yeah.
So I do. And then modern panels, 200 amp service, AFCI and GFCI protection and ample expansion space. So that's why I do a little field audit. I think we did this in a previous webinar. I kind of get a feel for, I mean, if every breaker is filled up and they got a couple twins in there, if it's 2,000 square feet or bigger house, I'm telling them that their panel is at capacity and they should consider going to 200 amps. And a lot of times it's a 100 amp panel and they go, oh, we want central air conditioning. Then I'm telling them they really should go to 200, because even though I go into houses with 100 amps and central air conditioning, there's not another lick of space or another drop of amperage to put another circuit in there. And most people do, when they move in a house, probably have a need for a circuit here or there. So,
Right.
But the modern panels will have the AFCI and the GFCI protection,
Right.
even
We
more now in 2023.
Yeah, if you'd like further information on outdated panels, we have a webinar, a recorded one on our website under electrical, Bad Boy Electrical. And if you haven't seen it and you're not in Massachusetts, you can get credit. You can just pull it up and watch it and fill out our form. Panel clearance. Adequate working clearance around electrical panels is critical for safety, maintenance, and compliance with electrical codes. This clear space allows electricians and homeowners to safely access the panel for inspections, repairs, or in emergencies, and reducing the risk of accident contact with live components or arcing. So we have to be practical. And I like to see 3 feet in front of the panel. That's what code is. On the side, they're saying 30 to 36 inches. We've all been in that ranch or cape where we go to the bottom of the stairs and that panel's jammed against the foundation. So you're not always going to see the clearance on either side, but you definitely want to see the clearance in front. You'll see a lot of homeowner special. They finished the downstairs themselves. The guy's got carpentry experience. The downstairs looks great. You're down there. And then where's the electrical panel? Well, it's behind the bathroom. And you go in there and there's a foot and you're squeezing in there to take a look at the panel. And I'm like, there's just not the space there. And the client will look at you and go, well, how big of a deal is that? And I'm like, well, if someone opens up that panel and gets arc, they can actually bounce back and forth and get electrocuted. So we want to have 3 feet of clearance in front of the panel. Most important. Again,
so, here's one I did a couple weeks ago. It was built like that. There's no 30 to 36 inches on the left side of that panel. But look at, I couldn't get it far enough away to take a shot, but there's the water line going to the water main. You take 2 steps with that cover off and you're walking into the water main on the floor.
Right.
So that's, and look at that rat's nest there too. That's a mess.
Not done neatly. Clearance from gas meters. The required clearance between an electrical panel and a gas meter is not set by the National Electric Code directly, but by utility company standards and local code amendments. The general rule, the minimum horizontal separation on most gas utilities require 36 inches between the electrical service panel and other ignition sources and the gas meter regulator. Vertical clearance, if the electrical panel is above the gas meter, at least 3 feet vertical, vertically is usually required as well. So we want 3 feet away from gas meters. Working space in front of the panel, we talked about that, is 3 feet, 36 inches wide and 36 inches deep in front of the panel, kept free of obstructions. Why does this matter? Gas meters and regulators can vent gas during pressure relief or malfunction. Keeping the electrical equipment at least 3 feet away reduces fire risk. I call this out a lot of times. There'll be houses without basements. And I've done a couple of houses where I'll go in, there'll be a utility room on the connected to the house. You'll see an electrical panel, a gas meter, a water heater, and the heating system all jammed in to a 5x5 room, if that big. And I call it out, and people are just like, well, it's been that way for 50 years. How are they going to move the gas meter? It's not my problem. Call the gas company. It needs to be moved, or move the electrical panel, or just be aware of what's going on. So that's the clearance from a gas meter. I'll take this one and then you're up next. Documentation requirements, amperage and voltage. And we talked about this in the state standards, and most states are the same that we're in. Inspectors must document that amperage and voltage rating of the service, the panel location, the location of the main disconnects and sub panels must be recorded, and the wiring methods. So the main panels in the basement, the sub panels in the basement, the garage, an attic, you've got to put that in the report. I usually do that in styles materials. So that's what you have to put in on a requirement.
So aluminum wiring is a huge concern, correct? We don't have the years here. Was it 60 something to 70, whatever they were using aluminum?
It was 78.
78?
I think so.
So inspectors must report the presence of solid aluminum branch circuit wiring. The aluminum wiring can pose fire risks due to its expansion and contraction properties. Aluminum wiring typically has a silver color compared to copper's reddish appearance. Now, a lot of people confuse the aluminum with tinned copper. And if you saw them next to each other, you can see the difference. But normally there's a little nick in the tinned copper someplace that will give it away. But it is a little bit darker and inconsistent.
The copper dipped in tin also has a fabric sheathing.
Yeah, the sheathing is different.
Yeah.
So it needs to be called out, and there are proper connections that can be fitted to the wiring to make it safe, or replace the wiring whenever possible. But sometimes it's difficult.
And for the new inspectors, Stan, that's solid branch aluminum wiring, not the stranded.
Yes.
Right, because the stranded wire you have that bite of the screw holds that wire in much better. All right. Okay. Well, mid-70s.
Yeah.
What is solid branch aluminum wiring? Mostly used in 65 to 70 for 15 and 20 amp breakers. It looks like copper, but dull silver gray in color. Again, thermal expansion and contraction, we call it cold creep. The wire heats up, cools down, and it will move. Oxidation, galvanic corrosion. If the aluminum is connected directly to copper or brass without proper connectors, a chemical reaction can occur. Mechanical weakness. Aluminum is softer and more brittle than copper, and it's a fire hazard. Again, the overheating. Most of you know this. So this is a good example of the solid branch aluminum. Now, I'm here in Cromwell, and we have on the west side of town, we have a lot of condominium complexes, and the town fire marshal made the complexes switch all the panels out so that they could handle the aluminum branch wiring, because they were tired of going over there for fires. And they had to have every single outlet bonded to the wire. So it's no joke. I know in Cromwell they had a couple of fires because of that, And now when I go into pretty much any condo in Cromwell was built in the 60, 70s, they're all new square D panels that, I think Newington Electric did them all. I'll continue with this and you can take the next one. Solid branch aluminum. Again, warm or scorched outlets and switches, flickering lights, intermittent power to receptacles. You're going to smell burnt smells. Correction methods, as we talked about, replacements of best option, rewire with copper. And then you can get crimp connectors, special crimp connectors, but you need a trained electrician. And again, you can bond these things together, solder them together, but it needs to be called out in the report.
So copper dipped in tin or tinned copper. It's copper conductors that have been coated with a thin layer of tin. It's not aluminum. Sometimes inspectors mistake it for aluminum because of the silver gray color, but it is actually copper underneath. It was corrosion resistant, so the tin coating helped prevent copper oxidation, especially in damp or coastal environments. And older wiring from 1930 and 1960s, the tin made it easier to solder connections. Durability to tin copper resists chemical reactions that can degrade bare copper wire over decades. And you'll see it in older panels and branch wiring offer often cloth insulated non-metallic cable from the 40s to the 60s in marine, industrial, or high moisture applications, even in modern systems. So there was a purpose of it or for it. It's still out there, and I don't think there's any real defect to it, but you need to be able to differentiate it from aluminum, basically.
One of the things I heard, I had an electrician tell me, I don't know how true it is, but a lot of this came about during the war because there was a copper shortage. And electricians needed a certain thickness to the wire, so they gave them a certain diameter they could use for the copper, and they dipped it in tin to get the rest of the thickness that they needed. You want to continue?
Sure. So copper dipped in tin is safe to use. Tin copper is considered high quality conductor and doesn't carry the issues of aluminum wiring. Do not confuse it with aluminum, as we had already said.
Yep.
Always verify with a scratch test. I wouldn't do that, or by checking the label. Aluminum has different inspection concerns: expansion, contraction, oxidation. As with any conductor, ensured terminals are tight, no overheating is visible, and that the wire gauge matches the breaker size. In a report, you typically note the branch circuit conductors in the panel appeared to be tin copper. This was a common practice in the mid-20th century wiring to resist corrosion. These conductors are copper-based and generally acceptable if in good condition.
Inspection limitations. Remote controls, we've gone over this. We're not required to inspect them. Alarm systems and components were not required, and solar systems and on-site generations not required. You'll have clients look at you and go, I'm going to test the smoke detector. And I go, no, don't do the smoke detector. Why? Because if it's on an alarm, the fire department's going to come and it's like $150 fine because there's no fire. So we're not going to touch alarm systems or smoke detectors, that kind of stuff. You can answer as many questions as you want. Can I have it switched over? Yes, you can call the company. But that kind of stuff. I don't inspect solar systems unless I see cracked panels, fogging panels, an older system. I do put in my reports that it wasn't inspected, but I also put in the report that you should do your due diligence to make sure what the contract is, if you're happy with the contract, if it converts over to you, is a good deal for you, and have an attorney look at it. If you're viewing this as a recorded event, your event code is EW 673H4. Crazy code. Go ahead, Stan.
So technical limitation. No measurement required. Inspectors are not required to measure amperage during standard inspection. Voltage measurements are outside the scope of the standard of inspection. And in electrical circuits, impedance is the total opposition to flow of alternating current measured in ohms. Impedance testing is not a requirement for home electrical inspections. I got it, Jim.
Okay.
So the service entry components, not part of the electrical panel, but I think it's important to mention them. So the service drop, the overhead wires bringing electricity from the utility pole to the building, entrance conductors, wiring connecting the service drop to the meter and the main panel, and the main disconnect switches that cut power to the entire electrical system when needed.
Um, for newer inspectors, anything connected to the house is an electrician. Past the house is Eversource or your local utility company. So you'll see this and you'll call out the frayed wiring and the client will go, well, I'll just call Eversource and they'll replace it. Or there'll be a problem with the drip loop. I'll just call Eversource and they'll fix it. No, it's connected to the house. It's an electrician that's got to do it. They will work with Eversource if they need to. So I had a situation in Cromwell where I called out the drip loop being too low, too dangerous, and they Eversource refused to. Part of what they had to do was raise the wire on the pole for some reason. I don't know. They refused to do it. It was a big nightmare, but that's what that is. Proper drip loop. I think this is your stand, but I would call this out. No mast too close to the gutter. That's dangerous. That's really dangerous. You go work on your gutters and you hit that, it's not a good day. Height of cables crossing over the property. 12 feet required over driveways. And I think this is a picture that you took, Stan, right?
So over the driveway on the left, it's more than 12 feet.
Yep,
But,
right here.
but
But
near the
then,
house,
yeah,
I could jump up and almost touch that wire as it passed through those trees there. So I called it out and I told him you got to be very careful, but I would see if there's anything you can do to get that higher, because that's not
right.
over the driveway, but that's pretty low.
And you don't want it going through the trees either.
Well, that was a separate comment, but
Yeah.
um,
Electrical meter. There's one. Let's see what we got. Invisible mast. Stan's laughing because I didn't really think this was a big deal. Stan yelled at me while we were going over this and said, yeah, you're going to start calling that out because if there's a problem, you can't see it.
you can't remove the wire. You got to pull the siding off. That's just not a good thing right there. And I see it occasionally, not a lot, but occasionally. Because they didn't want to take it off the house and put the siding behind there. That's ridiculous.
Yep. Electrical meter, often called the utility meter or electric meter, measures how much electricity in a home consumes so the utility company can bill the homeowner. How it works. Electricity flows from the utility service lines into the home through the meter. The meter tracks the amount of electricity used, usually in a kilowatt per hour, using 1,000 watts per hour. Modern meters are often digital smart meters that transmit data wirelessly to the utility. Older meters have been a spinning dial mechanically that records consumption. Purpose allows the utility company to bill based on actual usage, provides homeowner with the information on energy consumption, acts as an interference between the utility and the home's electrical panel. Location, typically mounted on the outside of the home, often near where the service droop or the service lateral enters, connected directly before the main disconnect. Inspectors do not remove or tamper with the meter, the utility equipment. Check that the meter is securely mounted, free from rust or damage, not loose or pulling away from the wall, weatherproof or sealed. So I'll just continue on a little bit here and Stan can do the next slide. A lot of times what you'll see is just some minor rust and stuff like that. You still call it out. If you see painting's been done or siding's been put on, sometimes you'll see those meters just flopping in the wind there. And also the other thing on the service drop, you'll also see plastic. If they're doing gutter work or painting, Eversource will come out and wrap that in plastic for safety. You have to call them to come back and remove it. They just don't automatically know. A lot of times I'll do inspections, I'll see the plastic there, and it's been there for 6 months, and no one's removing it.
So grounding and the importance of grounding. It's a safety function. Proper grounding provides a path for fault current to safely discharge. Check ground rods, grounding electroconductors, and panel connections. And most common issues, and I think we've all seen these, loose connections right there. If you can move that thing, you got to get that pipe. Sometimes I'll tighten it up, but sometimes you shouldn't do that, because if something happens, they say, well, Stan fixed it while he was there. It's his fault. I stopped helping people during a home inspection, and just write it up. Improper materials or inadequate grounding paths are some of the issues. So poor grounding, missing grounding rods, system lacks proper earth connection for fault current, improper connections, loose or corroded ground wire connections reduce effectiveness, undersized ground wires cannot handle fault current safely, and metal components not properly bonded to grounding systems. So there's quite a bit going on. It might not look like it, but there is.
Your event code, if you're watching this as a pre-recorded event, is SJS 9375D. I don't know why these are so long. Fixtures and receptacles. Inspector must check a representative number of fixtures, switches, and receptacles throughout the property to ensure proper installation and function. This has become an issue for at least me. I will go into a room. I do more than the representative number, but there's furniture, there's access issues, people are moving, sometimes there's storage, and I will get the call every once in a while, this outlet's defective. I'm like, okay, put a new outlet in. Did you read the report? It says that a representative number of outlets was tested. We do not test every single outlet all the time. And that's important for report writing. Ground fault circuit interrupters, wet locations, kitchens, bathrooms, outside, garages must be tested to verify proper operation during inspection. Those are ones I do test every single one I can get to. Panel GFIs can be installed at breaker level to protect entire circuits. So you'll go in, you'll do a 50s cape, you'll see no GFIs in the kitchen. The client is 85 years old behind the whole side. This just happened to me. They didn't even want to go into the basement for the inspection because they couldn't walk down the stairs. I said, you need GFIs. And the husband said, I will just put a GFI breaker because he knew stuff. And I said, you're not going to do that. Why? Because there's no way for you to go down and reset it. You're going to have to change all the breakers in the kitchen so that they can be reset at the outlet. So that's important. For younger people, I'll tell them it's probably easier and better. The breakers last longer. They're just as reliable, but you're going to have to walk to reset it if it does trip. GFCI outlets, what are they? Basically, GFI outlets are going to determine the interrupted supply of electricity by moisture. Okay, so moisture flows at a constant rate at a certain frequency, and if that frequency is interrupted, the outlet will trip. They're required, like I said, in bathrooms, kitchens, garages. You need one in an unfinished basement. Outdoor receptacles with good covers, and laundry areas. This says 6 feet within sinks or water sources, but you know, you'll go in, you'll do a house, you'll see one GFI to the left of the sink, and the rest of them are not. You want everything in a kitchen today to have the GFCI outlets, and there needs to be a GFCI outlet in any islands. I'll keep going. You get the next one. That has a test and reset button on the face. You're going to test the button, or you'll have a tester with you. And then you just want to make sure those are working correctly. And a good narrative we have here: GFI protected receptacles were installed in required locations. These devices reduce the risk of electric shock and should be tested monthly using a test or the reset button.
So AFC outlets. An AFC outlet arc fault current circuit interrupter is a type of receptacle designed to protect against electrical fires caused by arcing. Continuously monitors the electrical current for patterns that indicate arcing, or if you want to call them spark. If it detects dangerous arcing, the AFCI quickly shuts off power to prevent overheating and fire. So, for instance, you got an outlet behind your bed. Your lamp is plugged into it. Every time you get in and out of that bed, you're pushing that bed against the plug, and the plug is wiggling. It could create an arc. If it's enough arc, this guy's going to detect it. That's why they started in bedrooms first, but they are beginning to be required in a lot more electrical outlets. The standard breaker protects against overload and short circuits, but they do not detect arcing. And arcing can happen when wires are damaged or loose, insulation is deteriorated, cords are pinched, stapled, or bent. So they significantly reduce the risk of electrical fires. Now, when my kitchen was remodeled, we had a bunch of arc faults now, and my house was built 1942. And two of them were just not, they were constantly tripping. So the owner of this home decided to swap the two, just for shits and giggles, and they're both having tripped since. So I don't know what the difference is. Maybe they were too sensitive for that circuit. I don't know, but they're both sitting there. I don't even care if they detect an arc. I lived in this house for 37 years with no arc faulting. But anyways, next slide, Jim. Most living areas in a home, including bedrooms, living rooms, dining rooms, hallways, and closets. They'll in new construction, that's where they're going to be required. Often required in combination with GFCI protection in some locations. So dual functioning AFCI, GFCI devices. Looks similar to a GFI outlet. Often with test and reset buttons, will trip if arcing is detected, not just when the ground fault occurs. So arc fault circuit interrupters outlets were observed. These devices are designed to reduce the risk of electrical fires by shutting down circuits when dangerous arcing is detected.
Professional reporting. Your report is your report is often the only lasting product of your inspection. You want to make clear observations, describe what you saw, use factual language, avoid vague terms like poor or bad. Instead, describe the actual condition. Explained implications helps clients understand why the condition matters. Uh, Connect observations to safety function and longevity concerns. Actionable recommendations provide clear guidance on the next step, typically recommending evaluation or correction by licensed electricians. Document limitations, know any conditions that prevented complete inspection, explaining how the limitations affected your findings. We're going to go through some of it. So I know I've been changing my report over the last year, and this has helped me greatly and cut down on my phone calls. You want an observation, what you saw, factual description of the condition using specific technical language, including location details and relevant specifications. Example, the electrical panel located in the basement utility room contains two Federal Pacific stab block breakers, two conductors terminated under a single terminal double tap. Implication, why it matters, and that will explain what we've gone over, that this is a fire hazard. Then a recommendation, what to do about it. You're going to provide clear action items recommending evaluation by a licensed electrician. And then limitation of inspection. Inspect what you couldn't inspect. Know any conditions that restricted inspection, explaining why. This is huge because what I tell my clients is when I inspect an electrical panel, it's for certain things. When the electrician comes to fix those things, if I find anything, they may find several things more that's outside my scope that I don't even know that's wrong. So don't be surprised. But by and with my reports, by putting the implication in there, it's just the calls from the agents have stopped. A lot of the newer agents aren't as trained well as the older agents. They haven't done the number of inspections. So when they get a report that just says, oh, there's a double tap, get an electrician to fix it, they don't even know why it's bad. By having the implication in there, they can read it and then use that to negotiate or to answer any questions that they have. Double tap breaker narrative. Observation: the electrical service panel contains at least 2 breakers with 2 conductors terminated under a single terminal. Most breakers are designed for 1. That's the implication. And then the recommendation is by a licensed electrician. Federal Pacific panel. The main panel is a Federal Pacific panel with stab lock breakers. Implication: the panels have documented performance issues. Recommendation: let's get a licensed electrician out there. So again, observation, implication, recommendation, and then limitation of inspection, if there was any. Case study: a newer home, 15 years old, presented well with modern electric panels showing no obvious defects on visual examination. Circuit directory was complete and legible. No signs of moisture damage or modifications were visible. The inspector proceeded with cover removal for the interior inspection. Upon removing the cover, the inspector discovered multiple double tap breakers hidden from view. More concerning, several connections showed discoloration and slight melting of the wire, evidence of overheating from loose connections. So this is a case of why you got to take the panel off. And as Stan talked about earlier in the webinar, you go into, especially like apartments, like West Hartford, you get some of those apartments, those people paint right over those electrical panels, and you're not, even with an X-Acto knife, I won't break the paint because I'm going to get a phone call that I have to repaint the whole apartment. So we got to take panels off, but if we can't, we recommend that an electrician should do it. You want to go, Stan? Finish up? We're
Sure.
almost done.
So I think when we talk about comprehensive inspection, if there's 30 people online tonight, we're probably all going to do something a little different. We're going to hit the majority of this together, but we all probably have a little different slant on a lot of things, leave some things out, add some things out. I said it before, and unless you're an electrician, you're not an electrician. So be very careful about how you portray what you're finding. And these are common defects that we see visually, that we can see when we take the cover off or as we're walking through a house. So those are the things that we really want to be aware of. The documentation, make sure you do what the standards say we have to do, what the state wants us to do at a minimum. And then safety first, make sure that you are protecting yourself and the people that you're working with. I think that it's extremely important, and I could say this at the end of all these webinars, no matter what component we're talking about, to document the things that you could not see and do, what restricted your access. And I always say that they should be moved, or access should be provided and inspected, because especially with this component, there could be hidden safety items that really need to be found. So to me, this is one of the, besides the actual structure of the house, the foundation, things of that nature, this is pretty important. So I hope you take away something. I know the veterans probably know all this. It's a review for the newer people. Hopefully we've enlightened you a little bit, but this is a critical component of the home, and we got to get it right. So, all right, we have time. Oh, we're over. Thanks,
Yeah, we're
thanks
over,
for hanging out.
Yeah, so we did good. As you can see, we have our Cornerstone logo here, which is available for download off our website, that if you want to put on your website. And also all our webinars now have our logo for attending that you can put on. This is kind of a little bland, but we have more fancier ones on for other webinars. Those, if you go to logos for download on our website, the password is Cornerstone. So you can log in there and you just drag your logo over onto your desktop on the home screen, and then you could upload it to your website. And again, thank you for attending. December 2nd, we have Radon and Air and Water, and then our Connecticut Law Seminar, January 5th and 6th. And check out our calendar of events. If you have any friends that are inspectors, let them know about us. Tell them about us, the great job we do and how convenient it is. We could always use more inspectors. Thank you for attending.
Thanks, guys, gals. Thank you very much.
Thank you.